Number 4. It's getting quicker and quicker, I promise. Right. So we've talked about detecting failures, making sure you fail, and who decides what to do when you fail. But what should you do? Right? When your code craps out, what state's everything in? You mentioned there about having emails when you've got this global exception handler that sends your emails. Mm-hmm. What else does it do?
Logs as well.
Logs, okay. We'll come on to that.
It also detects whether the email sender's not working as well.
Detects the email sender's not working. Okay. Right. What about your database? What state's your database left in? Who knows? I appreciate the honesty.
No, partly because I'm using a third-party package, like Doctrine. So I don't exactly
My sympathies.
I don't know what's happening within that. So I can. Although it's done in a unit of work, and it is all done at a fairly narrow sort of point. If that fails, it's somewhere halfway through.
Right. Okay.
I don't know what it does, to be honest.
All right. That's a fair assessment. Don't know the situation. It's a fair assessment. So if we come back to our statement earlier about robustness, robustness happens whether you like it or not. You can be prepared for it, or your app's going to crash and burn. And we've already said, step 1 is know that you need to fail, and step 2 is make sure that you fail. And the third step is don't leave a mess behind when you fail. In PHP, because the PHP runtime engine wipes everything clean in memory and starts again from scratch every time, PHP code tends to be more deterministic and more reliable than code written in other languages. Because other languages, you've got an app server model where the process starts up and it's running and it stays running for days, weeks, months at a time with state in memory. And with those, when things crap out, you've got data structures in memory to repair as well as your databases. We don't have that with PHP. Every time your script starts, it's starting from a blank slate, at least in memory. So it's easy to forget that you've got all this other state that you've got to deal with when things go wrong. Because if you don't deal with it, the next time someone calls your app, it may not work at all. It may try and load something from the database, and if you've got partial data in there, you're actually propagating a bad piece of data. You're back to triggering more robustness problems, but your bad input's now in the database where you're not expecting it. Hardly anyone checks the data they get back from the database to make sure it's sane. They assume that because they're the only one writing to the database, every time you read from the database, the data you're coming back is safe. So if your database is garbage, you're in a whole heap of problems. And normally, someone has to go in and manually repair it. And if that's production, and you're a website turning, say, like one of the ones I mentioned earlier, is turning 60 million plus a year over, that costs. That costs real money. An outage can easily cost £250,000 to £500,000. Because, of course, most websites don't do their business spread over 24 hours because humans tend to be most active during certain hours. So you have these hotspots. And if your system's down during that hotspot, you lose a lot of revenue depending when these problems happen. So you've got to be careful with it. So what are the things you may have to clean up? It's mostly to see if you're awake, I guess. See if I bored you all too much. What are the things we've talked about state?
The database.
Database, that's one. What else have we talked about?
Depending on how your system works, some of the output to the browser might have propagated.
That's a very good one. So if you're not using output buffering, you may have already sent data that you can't get back, which can be a real problem.
Or part of the buffer might be full and you need to clear it.
Buffer's full, we need to clear it. That's a good one. I must admit, I tend to set the buffer larger than anything I can send back to deal with that. It's also a very good PHP performance trick. That way the communication between PHP and like Nginx or Apache is as fast as possible if you flush the buffer in one go. Yes, please?
Session state.
Session state, yep. Anything else?
Well, when it's your
Memcache?
Queues.
Queues?
Any sort of API or anything you write into the file system, you might even...
File system, that's a very good point. And if you're dealing with payments, the payment gateway, remote system that you're talking to as well. Any sort of third-party API you're talking to that you're acting as a bridge for is also important. So the basic principle here is you want to reset things. When something's gone wrong, you want to put things back to how they were before it went wrong. Because otherwise your system's in an inconsistent state or an unexpected state. So that's the basic principle. That doesn't say don't log. A lot of people see this and go, oh, I can't log anything then because I'm changing, because obviously logs are a form of state, you could argue. But you don't read from your logs in your application, so it doesn't matter. So we talked about PHP session contents, databases, data stores. Your file system's a form of data store. Changes to remote systems. Make sure you've got a checklist when you're writing failure code and go through it to make sure it's all covered, if it's relevant. Even if you just put a line through to say not relevant if it fails at this point in your code. But make sure these things are done so you reset back to how you are. Now, I promise this isn't a trick question. So things have gone wrong at your end and you've cleaned up. But you're responding to someone's HTTP request. So how do you stop things being a mess at their end? What do you have to do to deal with that? And there's two things we need to do.
Send a good error code?
Send a good error code. Absolutely first thing you do. And that's very important because PHP will return a HTTP 200 by default when things go wrong. Yeah, old code, but that's what it can do. And that one can be an absolute bastard to debug. I have seen people spend days going through that because they were checking API return calls, but not checking whether the API had done the work or not. So they weren't also inspecting the database with their tests. They were going, oh, yes, API sent HTTP 200, I'll carry on. Oh dear, nothing's working now, why not? Because the API lied. So these things happen, you've got to be aware of them. Anything else we need to do?
Give them a good error message to see whether something you could try again, or
good error message for retries. So retries is the important thing there for me. Error messages are a mixed bag. Depending on who's talking to you, the error message can be a security problem, depending on what information you put in it, especially when you're dealing with robustness rather than correctness. You've got to be very careful with that on some systems. But retries is the important part of that, and we're going to look at that in a moment. Anything else? Nope. Well, those are the main two. Tell them it's not their fault. Don't hide the fact your API's failed out of embarrassment or shame. Don't do it. I have seen people do that. Admit there's a problem and tell them it's the problems at your end in your code. Differentiate between inputs they're not allowed to send rather than inputs you're not handling correctly. So your input validation, that's where you return your HTTP 4XX codes if there's a problem. Once you're past your input validation, it's your problem. You've accepted that data at that point. And anything that goes wrong, it's a 500 code because it's your bug, not theirs. Doesn't mean they're going to be successful on a retry because, of course, you're going to have to ship a fix. But it's still the problems at your end. Be honest and open about it because otherwise you're going to cause people a lot of grief and trouble and waste a lot of people's time, including your own, because you don't think there's a problem. Because you're a sysadmin, or if you're the sysadmin, you look in the Apache logs and you go, oh, I sent a 4XX back. It's their fault. They sent me garbage. But it's your code that's actually breaking when it shouldn't do. So don't lie about error codes. And then retries. Make it safe. Make sure that if you've had to return a HTTP 500, that they're allowed to retry. If you're running a cluster of servers, web servers, depending on what's broken, it may only be broken on one of those boxes. It may have lost a network link to a remote service. It may have a configuration error on it of some kind. The file system may be full. That's a very common one, especially if you're writing a lot of logs to find out why your code's crapping out. Yeah, a number of times I've seen systems fill up with logs. So make sure it's safe to retry. And that's where idempotency comes in. You'll see a lot of people not quite go this far, but this is the whole hog. So at its core, I can submit the same request to you multiple times, but because it's the same request, it only happens once. It only takes effect once. And that is crucial in a large system for making retries work. Very crucial, that. That's how you do it. Only problem is, it's hard. Idempotency is probably one of the hardest things I ever do with design work when I'm designing a system. You have to design each request to be self-contained, not dependent upon the state in the database, or as undependent as possible. That can be very hard, especially if you're working with things that have got times in them. It's amazing how many people don't put a time in a message and just read the system clock at both ends. So at that point, your request has changed the next time you resend it through. Little things like that, they all add up. So the whole message here is don't crash land. Don't do it. Fail gracefully. Don't crash land. Reset the state. Tell the other person there's a problem and it's your fault. Be honest, hold your hands up. And then make your operations repeatable. You can't guarantee, if you've sent an error back, you can't guarantee it's the same system that's going to do the retry, because you don't know who's talking to you. If you've got a large system talking to you, and that could trigger a retry on multiple systems. It does happen. So you can't assume you're only going to get one retry when you've rejected something. Make them idempotent.